Here's how to solve a direct variation equation. The problem always starts out the same way. Suppose y varies directly as x. Write a direct variation equation that relates x and y, then solve. So we're actually looking for two things. The first thing is going to be a direct variation equation, and that's going to be in the form of y equals kx, and then we're going to solve. So let's start with y equals kx. And we're going to use the first part of the sentence here, first part of the statement, if y equals 8 when x equals 2. So let's plug those in. So if y is 8, we don't know what k is, but we know that x is 2. So now let's solve that for k by dividing both sides by 2. And that tells us that k is equal to 4. That is not a direct variation equation. That needs to be plugged back into here for k. So my equation is y equals 4x. And that's the first part of your answer. That's a direct variation equation. Now we're going to use that equation to solve. And the solving is to find x when y equals negative 16. So we're going to plug in negative 16 for y. And I have 4x. And now I need to solve that for x. So dividing both sides by 4, x is equal to negative 4, and that's my solution. Y equals 4x is the direct variation equation. X equals 4 is my solution. Let's take a look at another example. If y equals 4 when x equals 10, find y when x equals negative 25. So let's write our direct variation equation, y equals kx, and now let's plug in the first part of our statement there. So y is 4. I don't know what k is, but I know that x is 10. Now let's divide both sides by 10 to solve for k. Oops. So k is equal to 4 over 10. And let's reduce that to 2/5. That's not my answer. My final answer is y equals 2/5 x. And that is my direct variation equation. Now I'm going to use that equation to solve the problem, which is to find y when x equals negative 25. So y equals 2/5 x. So I don't know what y is. K is 2/5, and x is negative 25, and I'm going to write that as a fraction. Now I can do some simplifying. So y is equal to negative 10, and that's my solution. Let's take a look at a third example. If y equals 9 when x equals 3, find x when y equals negative 27. So using y equals kx, let's use the first part of our statement. Y is 9. I don't know what k is, but x is 3. Solve that for k. So k is equal to 3, and then plugging that into my direct variation equation, y equals 3x. And we're going to use that to solve the second part, to address the second part of the statement, to find x when y is equal to negative 27. So y equals 3x. When y is negative 27, 3 times x. Divide both sides by 3 to solve for x. And x is equal to negative 9. And let's look at one last example here. If y is 24 when x is 32, find y when x equals negative 48. So starting with y equals kx, y is 24, I need to find k, and x is 32. Let's solve that for k. Divide both sides by 32. So k is equal to 24 over 32, and dividing top and bottom by 8, I get 3/4. And plugging that back into my equation for k, y equals 3/4 x. That is my direct variation equation. Now we're going to use that equation to find y when x equals -48. So y equals 3/4 times -48 over 1. And doing a little bit of canceling here, y is equal to -36. And that's how you write a direct variation equation and solve a direct variation problem.